Hi, welcome back. I'm Florian Ruppel. I'm the moderator for this session. And what we had so far were two really great sessions, or three in general, but two tracks and one keynote. And now I'm pleased to announce our next speaker, which is Michael Geers, one of the persons who initiated the Micro Frontend movement and who is also behind the microfrontends.org webpage, which I think for many of us was the trigger point to get into Micro Frontends. Hi, welcome, Michael.
Hey, Florian. Thanks for having me.
Yeah, it's a pleasure. I'm also very happy that you made it here to Munich, to our offices, and that you are now giving this talk from the famous Marienplatz.
Yes.
Cool. So you brought to us today the Drugstore Store version 2. So I'm quite hyped. I already saw, of course, a sneak preview. So I'm very excited about your talk now. I'm honest, for the demos in my presentation later, I still use the version 1, but we will, of course, migrate very soon to the version 2 and show all the great things that you prepared for us. Can you already give a sneak preview in 1 or 2 sentences?
I guess I will just start the talk and then we'll start the talk with a little sneak preview, talk a little bit about something else, and then get deep into the Drugstore Store.
Awesome. So very excited for it. The stage is all yours.
Thank you. Okay. Hello, everyone. Today I'm here to talk to you about tractors and about micro frontends. So some of my favorite topics. Before I get started, a few words about me. So who am I? My name is Michael. I'm a software engineer, front-end architect. I love web technology, love building stuff with web technology. I love the openness about web technology. I've written one of the first books on the topic of micro frontends back in the days, Micro Frontends in Action. And as Florian already said, I built the microfrontends.org website. I work for a company in Bremen, here in Germany, which is called Büro für Informatik. And we build e-commerce systems or work with larger companies that have e-commerce systems. And in most of the cases, these companies adopt a verticalized structure with independent teams being able to ship features independently. So this is where I'm coming from, where my perspective comes from when I talk about micro frontends. Okay, so let's get started. The Drugstore Store 2.0. So as Florian already said, there is a first version of the Drugstore Store. The examples I show in the you see on the microfrontends.org site, and today I want to announce an iteration of it. So a new version of the Drugstore Store, and it should be a community project, an open project, which gives you material to work with and create learning material, or just check out what others have built. But more on this later. Before I go into the Drugstore Store and the new details, I go a few steps back to motivate why I think it's important to do this and why I've decided on doing this. So let's talk a little bit about learning. How does learning work? So for me, I guess learning works differently for different people. I'm a huge fan of learning by looking at stuff. So learning by example, seeing how stuff is built by having a close look at stuff or under the hood of stuff. So in the open source, in the software world, it's pretty easy. You can look at the source code and see how stuff is built and how the things work, how things lock together, for example. And this is the reason why when I created the microfrontends.org website, where my intention was to share the knowledge we gained when building our first verticalized architectures with modern JavaScript frameworks, how we solve concrete issues. And I thought it's a good idea not to express this in text, but to also show what this means in code. So this example is deliberately kept very, very simple. There are no frameworks in there, but you get the idea of which server owned by which team answers to what request, for example. And this was important to me to really show that, to make this touchable. And then a few years later, after publishing the website, I did a few conference talks, and then I got the offer from Manning to write a book about Micro Frontends. And I thought, nice. Now, a book is many pages, a lot of text. I thought, this is cool. So now I can build a really big example. So tell all about the stuff that you have to solve in a real application. But what I had to realize quite quickly after writing a few chapters is that a book's not a good place to build something that gets more complex and complex over time. So in the book, you try to explain dedicated concepts. So how does routing work? How does isolation work? How does communication work? And you can put them together, but things get quite complicated when you put different concepts together where there are different decisions and they interlock with each other. So I had to realize that I have to focus on the individual concepts, and I created code samples for each of those concepts. And if you know the book, you might have also seen this website. I've created it along with the book, where you can see all of the example code and look browse the code and see the concepts in isolation. So I built a lot of very small self-contained examples that only focus on, for example, routing between different framework applications. But this was a lot of fun, so I like building examples and explaining stuff by example. But what I was missing after writing the book was how these pieces fit together. So explaining the big picture. And I thought about, what I could do about it. And in the meantime, I was part of a lot of new projects where a new micro frontend project was built, a new architecture was set up, tech stack was decided, platforms were discussed or built, and in every of sometimes it was own projects where we were part of the building the project. Sometimes it's just consulting where we had locking points or architecture reviews. But in all of these new micro frontend projects, there was always this huge bunch of decisions you have to make before you can build a micro frontend application. You don't have to have an answer to all of these questions, but a lot of stuff needs to be decided before you can build something. So do you need an application shell? Do you want to share code? Do we need to share code? Do we want to build a single page application of single page applications? Do we need some kind of module native, whatever federation? Do we want to buy something as part of that solves a problem? Do we need discovery? How does a design system fit? There's a lot of stuff that needs to be decided there. And each of these decisions has an effect on other parts and on the final outcome, obviously. Otherwise, there wouldn't be important decisions. So what you can do to get more confidence by making these decisions is to build proof of concepts. So this is something that we do in all of this project. I guess everyone does it. So to get familiar with the tech stack and the decisions you've made. So most of the time, applications like this come out of a proof of concept. So something where you can click links and click buttons and add something, and counters are a really good example, really pretty example of when you want to show that something client side is working or some state is kept through navigations, whatever. And these work. They are functional and they're important in getting to the final result, to the platform you want to build. But most of the time they look pretty ugly. But that's fine, I guess. But what's not so good, you get technical confidence by these proof of concepts, but having a good idea of is the user experience, the final user experience the users, the customers of our software will get, is it good a user experience? How is the developer experience? Developer experience, maybe we get a feel for it, but user experience with the simple proof of concept, sometimes pretty hard to make a confident decision if soft navigation versus hard navigation doesn't really make a difference, whatever. So it's complicated. After making architecture decisions, or architecture decisions oftentimes end up on wiki pages where you have rules, guidelines, documentations, and about specific stuff. So how do we communicate? What other things we don't want to do in our architecture, for example? And this is pretty important that you have it, because when someone new comes to the team, or some other team did something my team didn't expect, for example, that we have something where we can point to and we can discuss and we can talk about. But oftentimes, if you only have these written rules and guides, they are often theoretical, they are abstract I guess they have to be a little bit abstract. And from an outside perspective, if you come new to a project and were not part of the design and decision phase, they are also sometimes hard to understand. And an example that shows what does this mean when we talk about navigating between different applications and keeping state via X and Y, how does this really look like in code? Which patterns do I have to look for? And this is something that's missing oftentimes. Now a little bit, not another topic, but something that where I come back to the learning by example, what I did earlier. Project that influenced me or was pretty valuable for me back in the day was To Do MVC. I looked it up. The first commit was by Eddie Osmani in 2011, so 13 years ago. And I guess many of you know the project. The idea, it was created in a phase where JavaScript applications, JavaScript frameworks were pretty new, and most of us built web pages using jQuery, for example. And then something like Backbone.js and Ember came along, and everyone talked about it, but no one really knew what it looked like. And the idea was they created an application, a to-do list application. You see on the right the animation where you can have a limited set of actions, but it's not so trivial. You can add stuff, you can check stuff, and you can delete stuff. And this application, the goal was build this application without any framework or with your framework of choice. So there is a Vue.js version, an Angular version, whatever version in. When you build a new JavaScript framework, I guess even today you try to do MVC to show how this application would look like in your new technology. And this is, for me, this was a very, very cool learning resource. And the same team that was behind To Do MVC created a project which is called Movies. I just discovered this project beginning of this year, I guess. This is the same spirit. So they have one type of application, a movie browser in this case, which is implemented in different frameworks, but this times more of these meta frameworks that mostly also have a concept of routing, of having different page types, data fetching, layouts, whatever. So you have an Astro version, a Next.js, a Nuxt version, and you can compare them. And this is how these look. So they all use the same data source. They call the public API of TMDB. So it's an open IMDb project. They all have a similar feature set. So they have a listing page, and then you can navigate down into detail of a specific movie or view via the cast, for example. But what I didn't like so much is that there was no predefined look. So the tasks were defined, but everyone came up with their own style of how to build this. I guess it was a conscious decision, but I would have liked if they were all the same. So the UX differences of these specific choices would be more obvious if you test them side by side. But from a programming, from the code perspective, how to solve specific issues, it's extremely valuable to see these projects. Okay, so last year I did a little bit of research for the Qwik in the Qwik framework. I really like the idea behind Qwik, so the movement on going from these heavy client-side rendered applications to more server-side stuff. So I guess this fits more with the e-commerce mindset I have. So where mostly server rendered applications are quite a good fit. And when researching Qwik, I remembered that 1 year ago at the Micro Frontends conference in 2023, Giorgio Boa did a talk about Qwik. So I rewatched this talk, and I saw that he had that he provided a GitHub repository where he did a sample project with Qwik and Micro Frontends, so different applications working together, and so really valuable for me. So I was able to go into the details. How did he handle a specific thing? How did he support streaming? Did he support streaming? What did he do there to make this work? What did he have to share? Really impressive and good to find this resource. And now I'm getting to the Tractor store. I would love to see more large Micro Frontend examples in the wild. So open projects where you can, as a developer, dig in and see how people solve specific issues. And yeah, this is why I thought, instead of writing a new updated version of my book, I want to invest my time in creating a more beautiful but also more featured blueprint sample application for the Micro Frontends community that you can use to evaluate, to test your stuff, and build something upon it. Okay, so the Tractor Store 2.0. This is the product page of the Tractor Store. This one looks pretty similar to the thing we saw before, I guess. So what's new is now we have a header. Header with the logo. This is something that wasn't in the first Tractor Store, but we still have a card button. We have recommendations. We can switch between colors. Colors is also new. Before we did have 3 tractor models, but no colors. But there's more. So let me go through the different parts that we've decided to include in this prototype. Yeah, as I said, more tractor models. So now when you want to build a listing page, for example, and want to think about how would navigation, how would paging work, there's a considerable amount of content you have there, and you can verify things with larger amounts of data. So we have 23 new tractor models and 48 color variants. So most of these tractors, not all of them, have different color variations. And on the product detail page, you can pick between them. You can put a specific color version into the basket, and so on. And all of these tractors obviously have cool names. They have also cool color names, and the detail pages also have a nice description text, so you can browse it later on and look at the content we've created there. We've also introduced 2 kinds of tractors. You might have noticed that some tractors are looking quite futuristic, so we decided to keep the classic tractor model, but also include some autonomous tractors, we call them, that are able to navigate their field independently, I guess. We still have 3 teams. The teams have a little bit different names. These are more aligned with the names we use in our real projects. So we try to name our teams along the customer journey and along the specific needs the customer has while doing online shopping. So at first, the user is in the explore phase. He wants to find out what's offered there. So homepage, product lists, recommendations are classical part of this. We also, in this example, included a list of stores, of physical store locations the user can go to. This was also part of the explore team here. We have the decide team. The team is responsible for really helping the user making the product decision. So do I want to buy the red one or the blue one or the autonomous one or the other one, whatever. And the decide team puts everything together and helps the user to make this buying decision. And then at last, we have the checkout team. The checkout name is quite self-explanatory. So this is the team handling the basket and guiding the user through the checkout process. So, and these 3 teams are used with this color coding in the example. And we have of course, new and shiny feature that weren't in the first Tractor store. So first feature at the bottom, we have built a little helper script you can include, and a little you can specify DOM attributes to signal what the team boundaries are. The boundaries don't have to be the same as here, so you can jumble them a little bit around if your integration technique makes life easier then. But you can highlight, show the team boundaries, so see who's responsible for what. But you can also disable the team boundaries, which would make it a lot easier to test the user experience. So give someone a laptop with this page open and say, okay, click through it. Do you notice something? Does it feel sluggish on a mobile device, for example, and without having the distraction of these outlines? Navigation. What we've done here is create. So we have navigation inside of one team. So color selection is you stay on a decide page and navigate between different colors. Here we are on a product list page. You have this filter where you can show all tractors or only the autonomous or the classical ones. You can navigate to the home page, but you can also navigate across teams. So product list, product detail, card page, that you cross the boundaries. And depending on what you're building, if you want to build a single sparse style application shell application, you can test this cross-level navigation. Like Catherine in the talk before talked a lot about Angular and nested routing. In this example, you can you can test out if this works as you expected. And there are a lot of, well, not a lot of, we try to put not too much in it, but enough to have the most commonly occurring parts of communication covered. So we have this color changing here where other parts of the page also update. So changing the product color updates the recommendation, for example. We also update the URL here. We have a little bit of state. You can add something to a card. The mini card reflects that. You see it on the card page. There's no server-side state in this example. We only store this in cookie, which you won't do in a real online shop, I guess. But we also have a store picker. Maybe you saw it. We'll wait for the animation to go to the checkout page. So we have a form example where inside of a form we have a picker element from another team. This is not a common practice, but sometimes you might face a situation where it is necessary to have a form with a foreign element inside of this form. The form is owned by team A, and the inside thing, a picker, for example, is provided by another team. And you can also try to build this communication with state and whatever. Okay, and to make it a little bit more fun, we also added a little bit of confetti at the end. So if you complete the checkout, fill out everything correctly, you get confetti. And because this feature should be, we also wanted the Tractor store to be a good platform to validate if the thing we are building, the amount of JavaScript we are adding, if this leads to good performance or if we get performance issues. So it was important to us that the base Tractor store, I will come to what the base Tractor store is in a minute, that this one with no technologies, no dependencies, reaches a LiDAR score of 100. So this is the baseline, and now you can go and add stuff there and try to keep your performance level at 100 or your desired scope, for example. So we have created a solid baseline with all the best practices implemented, and then you can build your stuff on top of it. Okay, so about the project, how does the Tractor store look? What is it? How does the code look? How can I build my own stuff, or how can I use it in my own projects, in my own prototyping phase? We've created two implementations. The first one we call it the blueprint. So this is the real version where we created HTML, CSS, and the routes, so the features, and also components, but very basic. Yeah, this is a really simple project. It's a GitHub repository. You see the URL below. I will share them afterwards. And you find a Node.js project there, and it is a monolithic project. So you have one npm start command. It starts a server on port 3000, and then you see the application there. But it is a monolith. We made it a monolith because we wanted to make it as unopinionated as possible, so you can build your own application on top of there. So there's no integration techniques there. There's a little bit of client-side JavaScript using custom events to make these clicking a button and updating the minicard work. But in all places where we could, we kept it as simple as possible. So this is not something you would do in production. You would, build a little bit more into there. We also didn't include a component model. We used ES6 template strings, which worked surprisingly well. So if you build template strings in combination with Prettier and code formatting, you get pretty close to how it feels to build a React component or a JSX component. But of course, you don't have the luxuries like XSS security and whatever. So disclaimer here, don't use this one in production, but this should be, this is why we call it blueprint. So the basic version that other implementations can build upon. And I guess the more interesting or more user-friendly, but yes, now we have opinion there. Implementation is the Preact implementation. So we have these two implementations, the blueprint and the Preact implementation. This is built upon the blueprint. The Preact application is client-side and server-side rendered application. So we have 3 teams. Each team has a single-page application that handles routing inside of their pages. And when we zoom out between these pages, we have a multi-page application. So we have Explore. When you cross from Explore to Decide, you have a hard navigation, and from Decide to Checkout, you also have a hard navigation. In Checkout itself, you now are back to to SPA style stuff with Preact, so a lightweight React version, if you want to call it that, with Preact router and Preact custom element for doing the widgets and the integration. And so we have server-side integration using ESI and client-side integration using custom elements, web components, and I wanted to explore how declarative shadow DOM feels like. So in the latest browser, I guess from a year from now, all of the major browsers implemented declarative shadow DOM. I wanted to play around with it. So if you want to see how declarative shadow DOM looks like, it's pretty good fit for combining server-side rendered with custom elements. You can see it there. So you can check out the code later. So we have no live preview of the Preact version right now. I will add this one later, but the other one you saw a link there, you can open up in the browser and see how it works. A level deeper, let's look at the code. So what comes with the tractor store? So here you see a screenshot of the Preact application, but the folder structure of the blueprint looks pretty much the same, just not with JSX files, but with plain JS files. We also didn't include TypeScript here because no opinions. But each of these teams has its own database JSON file, which contains a business-specific data model for the specific team. So we have no shared database, no global JSON file, whatever. Each team has its own database JSON, and in practice, you won't have to touch this database JSON. Just build your whatever you want to do, REST API, GraphQL API, or maybe include it if data fetching is not part of your proof of concept. Just inline the data structure into your JS bundle, whatever. It's small enough to do that. But we've created these database JSON files which include the teasers, for example, the category structure and sorting, filtering, whatever. All your data you need for that are in there. We have a database file for each of these team. teams. And from a component perspective, the blueprint already comes with a componentized model. So you have a button component, footer component, whatever, filter component that is used throughout the blueprint. So in the Preact version, I migrated these components from ES template strings and plain JavaScript to JSX to make this work with Preact and CSS modules, for example. Yeah, but you can make of it what you want. These components are quite simple, quite straightforward, I guess. Yeah, and you can also use the CSS packaging and delivering model you would like. So in the basic version, CSS is just uses BEM notation and manually prefix stuff. Here we have automatically prefixed stuff with CSS modules or with team boundary prefixes. But yes, this is what it comes with. And we also did not make a decision or would leave the decision open if you go server-side rendering, if you go client-side rendering, or as I did with the Preact example, combine server-side and client-side rendering. Depending on the area you are in, so most back office applications, I think the way to go is go client-side only. And you can definitely do this with the Tractor Store. You can build an application shell, for example, around it. And then just treat the application as a purely client-side rendered app. So there's no reason why we have to use a server component here, but we can if we want. Okay, and we have a README template, not really a template, but if you want to build your own application, so you can use the Tractor Store just to play around with stuff, use it for a proof of concept, and don't share the results with anyone. It's perfectly fine. This is why it's an open source project. But what I, and I guess the rest of the community would really like is that you build something in a specific configuration with specific decisions. Some of the decisions, I guess, might in all of these cases, that the outcome will be different because there's so much different stuff you can decide against or for or whatever. So yeah. So what I want to encourage you is to take this and implement the Tractor Store with your tech stack of choice, or maybe the tech stack you use in your company, whatever, and then share the result with the community. And therefore, in the Preact application, you see a README file where all the decisions are detailed in a table. So you see what client-side server, client-side integration is used, what we used for styling there. If we implemented a discovery logic, for example, or if we didn't, and it's so the idea is to make these implementations a little bit comparable or easily addressable for others if they find them. And we have hidden 2 bonus tasks in the Tractor Store. As you saw the feature set before. One thing you can do, and this thing is a task that comes up in our project at least very often, is how would a component system look like if we made technology decisions A, B, and C? Should we go with web components? Should we go framework specific component system, whatever? The button component is a really good candidate for extracting it out of these 3 teams. Oh, I guess at the time right now, 2 teams are using this button, and how it's implemented right now, it's copied code. So the button component is not trivial. So I don't have animation here, but this has a, when you press it, you get shadows and what is this very beautiful, but it's not simple CSS, I guess. And it makes sense to refactor this one out and make a design system with it. And so it also has properties and states and whatever. So I guess it's a perfect example to sketch out how a component system would look like in the Tractor Store. Another, if you still have time, you need a new challenge, you can do the mind game of what would we have to change? What do we need to do if we want to scale from 3 teams to 4 teams, for example? What things do we have to change? Who knows what about whom? So the task would be refactor the recommendation strip. You saw the strip earlier. It's on the home page. It's on the product detail page, and it's also on the cart page. It has color sensitive, so if you only have green items in the cart, your recommendations will be green. So there are algorithms behind there. You can look at them later. But the idea is to refactor out these this component, this responsibility, so delivering recommendations into its own team, into its own system. So we also provided a color. If you specify the Inspire team name at the border, you get this nice purple color, so it blends well with the others. Okay, so there are still a few other things I did not mention here, but I guess for now it's fine for you to understand what we are trying to do here. If you want to learn more about the Tractor Store, if you're trying to build a proof of concept or a series of proof of concepts, I encourage you to look at this project. And if you have the capacity to really do an opinionated implementation in a tech stack, you would like a few of the speakers that are here today also signal that they want to build their the Tractor Store and their technology of choice. Maybe later this day we will see a presentation with a tractor. I didn't know, but I know from one speaker that comes after me that wanted to get early access. You can go to microfrontends.org/tractor, scan the QR code. I will share the link later, and from there you can find the links to the blueprint, to the Qwik version, and look at it. And I'm interested in your feedback. So thanks for listening. If you need help building micro frontend projects, if you have interesting stuff that you want an external party to look at, call me. We like doing this stuff. And yes, thank you for listening.
Great. Awesome. Thanks a lot. And yeah, definitely appreciate that we now have some improved graphics here, and overall I also like to have the fourth team, as you know, so this is really incredible. All right. I think we have some questions from the audience. Let's go and let's maybe show the first one here from Manuel. How can we submit our implementations?
Yes, I wanted to do an issue template and stuff. I didn't get around to it for today. When you go to the Tractor Store website, on the bottom, there's a little explanation of what we expect from a good implementation to be added to the list on top of the page. And then you have a submit button, and this opens an email form. It's an email link. I will get this email and I will look at it and I will add it. Maybe I will streamline the process later on.
Awesome, but good to hear that we already have one process at the moment. Yes. And I guess then more implementations will roll in. I also see some comments, so let's just highlight them and maybe discuss them very briefly. Very nice for verifying that this can work with real working application and also different major versions of a framework. So I think in general that is the whole idea behind it, right?
Yes, being able to, what happens if team A decides to update a minor version, patch version, moved from Vue 2 to Vue 3, how does it break, whatever. It's easier to do this in a confined, more small, but complex enough scenario. Yeah.
Very nice, great. And I think also from Kari, one add-on to this is that he was just using to do MVC React as an example for creating a micro frontend proof of concept. But of course, this to do is always, on the one hand, it's of course great, but on the other hand, for micro frontends, I mean, I also did that in the past once, and it was quite great. But then on the other side, people might already complained you really need micro frontends for that, and of course yes. You're right, but it's still very nice to just show off that what you can do, right? Right. I think Pascal is asking about a GitHub pull request, but
you can. So the website itself, there's also a GitHub repository behind it, but this one, we have things to do before we publish this. So I guess where we will add GitHub pull requests if we open source the website repository that we plan to do. But if you see improvements in the blueprint, so a colleague of mine, a half an hour before before the talks, saw that I jumbled up a source that I missed a letter, whatever. If you find bugs in the blueprint, just submit pull requests there, as in any open source project. Yes.
All right. And also, of course, in the same spirit, the next question, sorry, my Hebrew is not very good, but how can I contact you to suggest some new stuff? Email, I guess.
Same email address as submitting, I guess, or just do a pull request. Yes, right.
Great. All right. So this is all the questions I see at the moment. With that, we see each other on the lunch panel again, and we are now doing the raffle. So thanks a lot for the talk, and have a great conference and great time.